Welcome to section 8.5, amortized loans. I wanted a good definition of amortization versus what our book had, so I looked it up on Google, and it says that amortization is the action or process of reducing or paying off a debt with regular payments. If you buy a house, if you buy a car, if you buy something that you're making regular payments on, most days those loans are going to be on an amortization schedule, as in you making regular payments. This allows the loaning organization to really reap the benefits over time, but it does take a lot of time for them to reap the benefits. So we talked in our Q&A about different mortgage companies selling loans all the time, basically for cash purposes, because some of them need cash now versus the 30 years that most standard mortgage loans are done for. But let's look at the equation and talk about the pieces here. So first we have P times 1 plus R over N to the Tn. We've seen this before. We use this for compound interest. Now in this case, P is going to be the amount we're borrowing. There's usually two money amounts here. It's either P or R. R never changes. R is the payments that you're making. So P usually ends up being the total value, sometimes called the future value as well of it. P would typically be bigger than R. And then you've got R times 1 plus R over N to the Tn minus 1 divided by Rn. We've seen this one before. We've used this already as well, back when we did annuities in section 8.4. So it's not like it's a new equation. I mean, it is, but it isn't. You've seen the elements of it before. And like anything else, it's the idea in every one of these problems of identifying what you do know to find what you don't know. All right, so let's look at example 1 on page 427. Assume that you have taken out an amortized loan for $10,000 to buy a new car. The yearly interest rate is 18% and you have agreed to pay off the loan in 4 years. What is your monthly payment? All right, so what they're asking for is the R value. The R value is the unknown value. Let's clear off the definition of amortization. We don't need that. Let's put in what we do know about this problem. It says that our loan is $10,000. Well, again, there's only two amounts of money in this problem. It's P and it's R. Since they're asking us for R, the payments, the P must be the $10,000. Next, we have the small R value. It says 18%. We can write 18%, but remember in the end, we always want to write that as 0.18. We care about the decimal of it, not the percentage part of it. It does tell us the time as well. It says 4 years. So we have that. And it does say we're going to be compounding it monthly. What's our monthly payment? It doesn't specifically say compounded. The fact that it says monthly means our N value is 12. And big R value is what we don't know. What is our payment going to be on this loan? Let's set this up so we can solve this thing. 10,000 is our P. Times 1 plus. The little r value is 0.18. And N is 12. To the power of 4 times 12. That's the left-hand side. Equals. Big R value, don't know, so it's going to stay R. We have a big parenthesis here. We've got a little parenthesis, and we have 1 plus 0.18 divided by 12 to the 4 times 12 minus 1, all divided by 0.18 divided by 12. It's probably more time in the setup than it will be in the calculation. All right, so next, let's go ahead and calculate what we have in the parenthesis next to R. All right, let's bring up our calculator and calculate. All right, so once again, we start in the inner parenthesis here, as in 0.18 divided by 12. So 0.18 divided by 12. Enter. Okay, plus 1. Enter. Raised to the power of 4 times 12. Enter. So right now what we've got is we've got this entire smaller parenthesis here next to R. We need to subtract 1. So minus 1. Enter. Divided by parenthesis. Don't forget the parenthesis here because we do have 0.18 being divided by 12. And while I don't necessarily have a parenthesis on my work here, we need to make sure that the calculator has one so it does things in the right order. Enter. So right now, next to our R value, we have this 69.5652, we'll call it. Let's write that down. 69.5652. Normally I do 3 decimal points, but since I'm going to write this one down and I'm probably going to have to use this value to get where I need to go, I'm going to go ahead and make it 4 decimal points. Now let's bring our calculator back and calculate the left-hand side of this screen. We've got 10,000 times 1 plus 0.18 divided by 12 to the power of 4 times 12. Once again, we're going to start with 0.18 divided by 12. I know we've did this a little bit on the right-hand side, but we still got to do it on the left-hand side. So 0.18 divided by 12. Enter. Plus 1. Enter. Raised to the power of 4 times 12. Enter. And finally times 10,000. That brings us to $20,434.78. But we don't really care for that number too much right now. We're going to write it on screen so we can keep track of it. But then we're going to bring the calculator back, and I'm going to get to the end of this pretty quickly. So our left side was 20,434 and 78 cents at this rate. But to find it, what we're going to do is we're going to divide both sides by this 69.5652. And that's going to give us our final answer, our final R value, our payment of what? Some amount of money. Let's bring our calculator back on screen. We still have the 2434 sitting there. So we're going to take that and we're going to divide it by 69.5652. And it's going to give us a final answer of $293.75. So pretty cool there. We used it to figure out what our payments would be. If you've ever bought in a house, one of the things that you will do is you will provide your mortgage company, or whatever company you're going to use for your mortgage, you think, your financial information. And they do kind of a calculation similar to this to figure out what your monthly payment that you can afford will be. And then they work backwards to tell you how much house you can kind of buy for that. So it's an interesting problem. And we're going to do something very similar to that, but the elements are here. Again, one equation with the elements you've already seen from other problems. I know you can do this.